So let's get started, right? So we have imported, so let's start with the regressor, right? So we have imported both the regressor as well as the classifier in here, right? As you can see, it's both k-nearest neighbors. So we have this. So now let's try to create a regressor, right? As I said, you can have a regression and then as well as classification for any model. So let's say we call it KNN, right? So we're going to start KNN like this, right? Initializing KNN, we can actually do KNN.fit of X. Remember, it's going to be X train and Y train. And then we're going to use Y train because Y train is a numerical value, right? It's the original estimated value as is. Therefore, we can just use X train. And then we're going to fit it. Now we can actually look at dot score, right, of X test and then Y test, right? So now I can see, oh, it's not so great, right? It's minus 0.22, so minus 22%. It's not so great. So this is the k-nearest neighbors regressor. So now let's look at, the classifier. So let's say we have the classifier, and then we're going to call it the same name, for instance, which might not be the best practice. But then we can actually say train, right? And then Y2, remember, why is it Y2? Because it's a categorical variable that we have created from the original estimated value, right? It has high and low. And now we're going to fit it. And now we are going to do KNN.score of, X test. And then Y2 test. Okay, so, I mean, yeah, it's somewhat okay, right? The score is almost the same as logistic regression, no better than that, but it's 82%-ish. So we can pretty much then look at only when the score is good enough, right? So the score means what's the percentage of you making the correct classification. So this is telling us that it's 28% of the time, we're correct, right? We're making the right prediction. So it's pretty good. So only when that happens, you want to look at confusion matrix, because then the source of error can be what? Type 1 and type 2, right? So that's why you want to look at confusion matrix. But before doing that, we kind of want to assign. So Y2 predict is equal to KNN dot predict of X test, right? So now we have Y2 test, which is like the true label, and then Y2 predict, which is like what we have predicted. You can see this is your type 1 and this is your type 2. Yeah, it's pretty good, right? So it's really good. Let's compare that against our, say, logistic regression. I think we did that, right, in the confusion matrix. Okay, so it's in here, right? So yeah, it looks, you know what, it's almost the same. I think it's almost the same, right? If not, this is better. But so this is really, it just tells you that KNN, you can actually either use KNN or logistic regression. And it also depends on like which one you value more, right? It's like, or which one will cost you more. If type 1 error costs you more, then you want to, your priority should be minimizing type 1 error. If type 2 error costs you more, then you want to minimize type 2 error as much as possible. So this is how you can pretty much determine which model to use, right? Which model to use and which features to use, as well as, going through the basics of the models that you can use from, sklearn, like this. So you have sklearn, right? The modules are pretty much linear model, has its own module, and then SVM, support vector machine, has its own module. Neighbors, right, has its own modules, and cross-validation, again, remember, train test split is very important, right? You want to train on the train dataset and test on the test dataset, so you don't want to mix the two. And also confusion matrix, as I mentioned before, is very important.